Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE. And our guest today is Tom Ruth, Vice President of Americas at Quuppa. Quuppa is a powerful technology platform for location-based services and applications that enables real-time tracking of Bluetooth smart tags and devices with accuracy down to a few centimeters. In this talk, we discuss the value of location data across a wide range of use cases, from tracking hockey team performance to hospital safety. We also explored the trade-offs in battery life, range, cost, and other factors that must be considered when selecting the right location tracking solution. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or to recommend a speaker, please email us at team@iotone.com. Thank you.
Tom, thank you so much for joining us today.
Thank you, Eric. It's a pleasure to be here, and we're very excited to represent Quuppa here on your call. And I'm excited for the next 45 minutes to an hour to discuss IoT and how we're changing the landscape of business in that regard.
Yeah, and I'm really looking forward to learning about Quuppa. I mean, this is a company I've known about for many years now, and I've really never had a chance to have a deep dive, a discussion with any of your team. So I guess we're going to get there today. But Tom, before we get into Quuppa, I'd love to learn a bit more about you. I think you've been somehow touching this space for 3 decades now, maybe even 4 decades. I don't know. When did you first start to touch the topic of IoT?
Well, actually, I came to IoT through telecom. And so I've been in telecom for just about 30 years. And most of my experience has been in disruptive technologies in that sector. And so my last foray was with BroadSoft. BroadSoft was just recently acquired by Cisco a couple of years back. They made a core services platform that enabled service providers to disrupt the market by entering and providing innovative services to their end customers, usually for business. That has now is more along the lines of unified communications. So it was disruptive in that it allowed a network provider to enter the market at 1/10 of the cost of what the legacy technology enabled, that was provided by Nortel and Lucent and Nokia and the like. What's kind of fascinating about that is that the solution, it was a core technology that required an ecosystem of partners to deliver whether it was, we're talking about endpoints, whether there was other network gear that was involved, as well as software to make the whole user experience more relevant for the end customer. That ecosystem approach and selling through channels was a unique challenge, because in most cases, when you're selling technology, it's always best to try to have a direct interface with your end customer. And that was one of the challenges that BroadSoft had, but succeeded, and was a multi-billion company, and was acquired by Cisco a few years ago and is now part of the WebEx family. I happen to know a former colleague who was based in Helsinki, and he was an Italian gentleman who had a football team, I guess, of all the Italian expats in Helsinki. One of his best friends came here to Washington and was in the process of opening up the Quuppa operation here in the Americas, and was looking for somebody who had experience in taking a technology to market in the guise that I just described, with selling through end partners, developing channels, and starting from the early stages with the early adopter types of partners, taking it to market, and through the continuum of late adopters and so forth. So as we cross the chasm, as it were. So that's sort of how I ended up at Quuppa, and it was a fascinating story because one of the founders, Fabio Belloni, explained to me that this is disruptive in a couple of different ways, and that the marketplace in general, when we're talking about RTLS, And I guess I should sort of launch into what Quuppa does. Quuppa is an RTLS company that we provide real-time location services. And that allows businesses to make informed decisions by knowing where things are, simply stated. And, while that's sort of that, I asked Fabio in our very first meeting, I said, isn't this sort of similar to RFID? And after explaining that it happens through the use of radio frequency technology, he said that's sort of our predecessor. So we're RFID on steroids, if you will. So taking it one step at a time, if you really look back, just to give you a little brief history, that RFID had sort of morphed out of the barcoding space. If you scan a barcode at a point in time, that gives you the information or the identification digitally. RFID is an extension of that. It allows you to use radio frequency for identification purposes. But what it doesn't do is provide you with location, other than if you can mark the location of where you are at that point in time where you read that data. And that's not a very practical methodology if you follow what I've just said. So this allows you to do everything I just described, plus provide the location of where something is. And the marketplace itself is somewhat jaded because there's, this type of technology has been around for a while. The marketplace is somewhat jaded about it because or as I like to say, once bitten, twice shy. So they proceed with caution whenever they hear that I can accurately provide positioning information of where something is using radio frequency-based technologies. So Quuppa, simply stated, is delivering on that promise right now today.
Okay, and later on in the conversation, I'd love to get more into what the system looks like in terms of how do you accomplish this? Is it gateways with triangulation, or what is the solution there? But before we get into the technology too deep, tell me a bit more about the business. So our audience is coming from different perspectives. Some people will be very familiar already with the space. Some people, this might be really their first deep discussion around the topic. So what is the core value proposition, or what are the types of use cases that you would be typically solving?
Generally speaking, by providing positioning information that allows you to make informed business decisions of tracking, whether you're tracking people or assets in a location, our strategy or our direction is to do this in a horizontal fashion. We are a very horizontal technology in that we're used in all these different verticals, whether that's healthcare, sports, or Industry 4.0, which I think we're going to be most of our focus will be today. And so being able to provide tracking information of where things are in a space is really the core focus of what our business does. What you do with that information is delivered by our partners. And that's how our partners use our technology to go to market. I really didn't give you much of I thought we'd dive into that in the go-to-market strategy in a little bit. Just to kind of explain a little further about our company, as I mentioned, it uses radio frequency. So the founders of our technology all morphed or came out of Nokia. In fact, this technology was a spinoff from the Nokia Research Center. And it's really been, it's a mature technology that's been developed since 2005, when Nokia decided that it was going to exit the indoor positioning space. Our founders were enabled to leave and start this company. So in 2012, that's when we got our birth. We were shipping product in 2013. Shortly thereafter, 500 customers, 2,000 systems, 180 partners. Later, we have literally been growing a little bit at a time in a bootstrap fashion. Through that time, we raised 20 million euro in capital in August of 2020, which was quite a feat. In that we, doing that in the middle of COVID is no small order.
Yeah, indeed. Okay, interesting. And then I suppose you're very horizontal, so you're working across a range of industries. In terms of the scale of the deployment, is this also highly differentiated or highly diversified? I suppose you have some situations where they're very much spot situations. We have tractor, we have some kind of device that maybe we have 3 of them and we need to monitor their movement. But I suppose you could also have situations where you might have 10,000 pallets that are moving between suppliers to your warehouse, to your manufacturing center, to the customers, and you want to make sure that you're not losing those pallets. So you know where they are, for example, which could be a much more system-wide deployment. Could you give us a couple examples of typical deployment sizes? Or
glad you asked that. I'll give you an industrial example. So, and I'll refer to this example frequently because it's fascinating in that it was a challenging environment. And as I mentioned earlier, there are some challenges to this type of technology. Some customers that are producing goods, and it seems to be a common statement that you would think that in this day and age with digitization methodologies that you would have trouble locating products that you produced. And that seems to be a common thing that we hear about post-production. So asset tracking from post-production through the whole logistical supply chain is a real challenge for a lot of businesses, especially if some of these products have, a half-life or have an expiration period. If they can't be outside for too long or they have to be in refrigerated environments, as an example. You'll find this actually in the steel industry where oxidization is a factor for things that can't be outside for too long or it taints or damages the product. But being able to get products through post-production, getting them on the trucks, getting them to the end customers, getting the end customers then to recognize that they have taken receipt of the product and then are able to then put it into use through their production cycle of whatever they're making, whether it's cars or refrigerators or what have you. That gets an additional tracking capability of a work in progress. So one of the things that we're finding is in this particular business is that it's more of a logistical play, both not only where we're tracking things globally, but also inside a facility where you have a lot of things that, a lot of products that may look the same, but, are differentiated because of their gauge or whatever it is that the core of the product that makes it different. So at the surface, it may look the same, but, they have different characteristics, obviously. And so being able to track them and have an accurate method to do so is often a problem for business.
Gotcha. And then it sounds like, based on our earlier discussion, that you are selling primarily through channels now and through maybe system integrators. So would these be then typically part of a larger solution where the system integrator is going to be either developing some customized software application or using something off the shelf, but basically providing a semi-customized solution to the customer? Or is it also frequently just plug and play? You have kind of a standard configuration. Maybe you can describe a little bit your tech stack. Are you also providing a software application around this, or is this something that's always provided by your integration partners?
That's a very good question. So, our go-to-market strategy, as I mentioned at the beginning, at our core are a bunch of radio physicists. I am not. I run the business development side here in the Americas. Our founders are all physicists, and they know how to provide you harness radio frequency technology to provide accurate positioning. The industries and the use cases for it and the handshakes and the language and being able to, whether it's healthcare or sports or industry or what have you, is not something that we're going to excel at. So as a go-to-market strategy, we realized early on what we were good at and not what, and what we didn't want to endeavor into a vertical that we knew nothing about. So we would let our partners excel at delivering the end solution to the customer. And that allows us to focus on the designing of the technology and producing a good position, and allowing our partners to do what they're good at, which is taking that position and then adding logic to it. If this, then that types of scenarios that, when you, based on position, maybe I need to summon workers that have a certain skill set in the production process. Maybe I need, through a logistical, being able to track things down whenever, the delivery truck is waiting to take it away, things like that. So We had one partner who had experienced all kinds of problems and challenges in their whole delivery and logistics supply, and just about being able to find things, help them excel and reduce cost out of and deliver products to happier customers.
Gotcha. Okay, makes sense. And then maybe one last question here around the market for you. Who would be a typical buyer here or decision maker? Are we talking about a factory general manager? Are we talking about a corporate level technology team? So I guess the answer here is also going to be it varies tremendously, but who would you want to be talking to at a company?
We don't sell direct, so our partners are the ones that are taking this to the end customer. I will share a funny anecdote, because when people mention IoT, that usually means the IT department gets involved. And I had one production executive who was saying, listen, I've got a logistical problem. I don't have an IoT problem. He forced everyone to use this language when presenting the solution. He said, because if you're going to call it IoT, then they're going to start coming in. My IT department's going to start debating: are we going to use Splunk? Or are we going to use Tableau to analyze the data? What is the best? Re-engineering the wheel that may have already been created. So in this case, it was an operations executive. A lot of industrial engineers tend to be the ones that are looking to improve the operations of if it's manufacturing that we're talking about, but those tend to be the actual user buyer.
Gotcha. Yeah. Okay. No, this is an interesting tension between IT and operations right now. And obviously IT is very, very critical and becoming even more so, but nonetheless, they're historically more maintenance organization, right? So this is often not the role that they are playing at organizations.
We typically always find ourselves working with them because, there is networking that's involved and so there is an element of that. And of course, it all has to pass security. And that's one of the points that we'll touch on here at some point.
Yeah, of course. We've been going through a very challenging 12 months really around the world now. And I'm curious how COVID has impacted Quuppa, because on the one hand, I think everybody has been a little bit budget shy around new projects. On the other hand, this seems like the type of technology that would actually be very useful when you're having trouble getting people on site and maybe working with more of a skeleton workforce. So what's been the impact of this this situation for you?
Well, I can't lie and say that it's been great, but there actually has been, with challenges always come new opportunities. And so while, yes, we have had certain projects in certain market sectors slow down, as an example, in healthcare, it's been all hands on to deal with this pandemic. And so a lot of operational improvements that we find in the healthcare space certainly got tabled and shelved. We've also have some partners that use our technology in long-term care facilities, and they were certainly among the most affected. On the flip side, industry needed to get back to work. And a lot of companies came to us saying, we found a way to use your technology because it is in real time, provides location in real time, that we can do social distancing and contact tracing for our workers so that we can create a safe work environment. So as a good example, what we will do is provide the location information of the items that we're tracking in a physical space. We'll provide that information to a software platform that is taking the data and we will build business rules around it that will say, if these two individuals dwelled too long together at a certain period of time, and they can define what that period is. And as we learned more during this pandemic, those characteristics changed in terms of some of the distances and some of the dwell times, depending on where you are and the type of environment that you're trying to track people in. And so you're also be able to use haptics by having a wearable that may vibrate based on a certain policy that was being broken. Like if you wanted to notify the employees, hey, you're all too close, you need to disperse. And so you can provide that kind of information back to each employee by providing this logic-based approach with the information we're providing that system. That not only provides the social distancing aspect, but also the historical tracking of where employees are in the workplace, if in fact there is somebody that shows up or tests positive, then you can go back and look historically who they've interacted with and who may also be at risk. So the idea is to get people back to work, with this technology. One of the things that we are very quick to point out, and we try to educate all of our channel partners who have developed these types of solutions, is that they need to do more with location. And this will probably be a mantra I'll mention numerous times. But the idea being that if you can solve for one problem because you've got this infrastructure installed, now you can start solving for other things, like perhaps in a factory environment, you can also create another worker safety application for collision avoidance. Perhaps you can also do some things that will allow you to track assets, as the previous example that I was giving earlier. So you could do all of that with one infrastructure. And one of the business challenges that we often find are that people tend to do things in a siloed approach. They solve one problem with one technology or one solution, and it has one ROI around it.
Yeah, this is the challenge that we've encountered. We do a lot of work helping companies develop their technology roadmaps. And of course, we don't provide our own technology. We're helping them to then choose the right suppliers. But we always try to differentiate between enablers and efficiency gains. And in the efficiency gains, you can usually have a very direct business case, which is quite straightforward. But the enablers, there might also be a business case there in terms of some immediate cost reduction or improvement in quality. But often the real value lies in enabling future use cases. And it's a bit more challenging there to explain the value proposition, because often it can be logically very strong. But if somebody is just looking at their P&L and saying, okay, but I need OpEx to go down, then you have to kind of have more of a longer conversation around how this is going to enable the organization to be stronger over time, but it's not necessarily going to have a 6-month payback period. I suppose you get into these discussions as well. Tom, I'd love to get now into the technology a bit deeper. One of these projects that we were working on recently, we used a solution. So had the challenge of basically having pallets come into the warehouse and then wanting to track the location of these around the warehouse. And we used maybe a cumbersome solution. It was put RFID on the pallets and then put UWB, ultra wideband, on the forklifts, so that whenever a forklift picks up a pallet, it moves it around and you know where the forklift is, because UWB, you can track location, and then RFID, you know what's on that pallet. So you have a reader, a UWD or an RFID reader on the forklift, so it actually reads the pallet. So a bit of a cumbersome solution, but how would Quuppa compare to that? Or what would be the infrastructure required for Quuppa to solve this type of challenge?
Yes, so that's an interesting challenge here. I guess the first comment is that ultra wideband, very very accurate technology, but it has its constraints and challenges to it. It is the reason the power requirements alone may provide a solution or a challenge to the solution. If you're putting this on the fork trucks, obviously there's probably a constant power supply, so that really wasn't going to be an issue there. But then there's the tracking of the assets itself. So with Quuppa, you have two different, in your example, you have two different technologies that's there to handle the identification and then associate the positioning of when that RFID was actually read. With Quuppa, all the assets can be tracked with an active tag. And similarly, the fork trucks would be tagged as well, providing position in real time at all times, wherever something is. The tags that we use are active, so they do have a battery requirement on them. The cost that we see of these tags is probably somewhere in the $10 to $20 range US. It all depends on what other sensors that you're placing on them. And again, if you're tracking hundreds of thousands of things, then probably passive RFID might be the better way to go. We do see costs of these tags going down. We'll talk a little bit more about that later. But one of the tenets that we find with our technology is that often we are compared frequently against ultra wideband. And again, while that is a very accurate technology, we are able to do it with a much lower powered tag, and therefore the cost of the tag is much lower. So one of the things that we've seen in other examples is that people were trying to track thousands of things, but they had remorphed their business around processes, around the limitations of the technology that they were using. And perhaps the cost of the tags were too high because of the power requirements that I was describing earlier. And so they only limited things to pallets instead of items that were on the pallets themselves, when the real need was to be able to track thousands of items on the factory floor. And so those are the kinds of examples where we find that our technology is a better fit because, again, you can solve both problems with one infrastructure. And it's easier to maintain, the battery life is longer, you're not replacing batteries, and so on and so forth, which is a practical challenge in a lot of tracking applications.
Tom, we've touched on a couple of the trade-off topics here. So power, accuracy, what else? Different types of data capture, latency, stability. Of course, when you're talking about moving around a factory, for example, you have a lot of metal in there, so that can cause some issues with data capture. So what would be the other trade-offs that you would typically be looking at?
When you asked about the trade-off, there's a couple of different trade-offs when we look at radio frequency-based technologies like this. One is if we're tracking an item that's fairly dynamic and moving around, the power requirements of the tag is usually the one thing that we're going to excel at because we're using Bluetooth, the power requirements are very low. In the environment where if you have a lot of items or thousands of things to track, that's going to be a much more cost-effective solution than, say, some of these other technologies. The accuracy that's provided with our methodology is going to be different than other Bluetooth solutions because we're using angle of arrival. And that is one of the things that differentiates us in the marketplace because we're able to provide precision where other solutions do not. Because of through the school of hard knocks and skinned knees, if you will, and learning along the way, we've learned that how to make our solution a little bit more scalable so that we can control the tags and communicate back to them in a way that allows us to change transmission modes based on what zone you're in. So as an example, or key off of acceleration data or accelerometer data that says, okay, the accelerometer was triggered, now start transmitting. So we can actually change policies dynamically on these tags that allows us to manage the battery life on them much longer. And that, again, allows you to do much more scalable solutions. And again, to contrast what we do in the marketplace versus a lot of other solution providers, I would suggest that, because of our go-to-market strategy, we have an open API. We provide the location coordinate information and allow our partners to deliver the solution. And that doesn't necessarily box us into any one type of solution provider or any one vertical market.
Can I ask a few rapid fire questions here just to gather details on the specifications? And I
Sure.
guess there's going to be ranges here. So battery life, what would be a typical change cycle?
So in our environment, I guess I'm going to answer it depends. And it depends because of the application. How frequently is that tag going to move? Usually we can apply a policy that says if we know where something's last known position is, then we don't need to necessarily hear from it. So the tag can go quiet after it sits for a while if it's not in motion. So a lot of the tags that we have are in transmit mode based on the trigger of the accelerometer that's on it. And so it all depends on how frequently that's going to move in the space. I'll give you a contrast. We have hockey players that are wearing these tags that are lasting like a season. Again, based on the policies and the way that I just described how we were able to communicate to the tag. That's pretty good considering that the tag is transmitting at like 30 hertz. In an industrial environment, we're probably looking at something that's probably, much lower than 5 hertz because you really just don't need that many transmissions on an asset coming from a tag that's affixed to an asset in that example. If you have a fork truck that's moving or an AGV that's moving inside the space, you're probably going to have that transmitting a little bit more frequently. We tend to say anywhere from 1 to 3 to 5 years. And again, that's also a function of how big the battery is on the tags. Part of being open allows us to have a tag ecosystem of partners. So we, while we make our own tags, but we've given the specifications to a large variety of tag manufacturers so that they can produce tags that fit a variety of different applications and form factors.
Gotcha. Okay, clear. Well, it's an interesting use case already. Is tracking hockey players. I suppose this is good for analytics, right? Understanding why.
Yeah, exactly. Well, and that's a whole fascinating separate conversation. But usually we try to weave that into the conversation, because if you can track a hockey puck or hockey players that are moving at lightning speed on the ice, then we can track just about anything else.
And then accuracy, I guess, we're tracking the location of a hockey puck. Also, you have to have a pretty high degree. But I believe your colleague mentioned around 10 centimeters. Is that an average? Is that a best case scenario? What would be the ranges for accuracy?
I would say that that's a best case scenario, because, and that's a function, we usually say sub-meter in most cases. And certainly in hockey, we're looking for 10 centimeters or less of accuracy. In that, because of the precision and the measurement of how they're using it. And they actually have a nice environment because it's nice and wide and open. In industrial environments, you have racks that go to the ceiling and so forth that can cause obstructions and so forth.
And then the range. So you have a beacon, or you have this transmitter or receiver, I guess, set up in the ceiling. And so I guess there's going to be a couple things related to that. One is how many tags per receiver. And then the other is, what is the range? How far can a tag move away from a receiver and still transmit data?
First of all, the throughput of the receivers, or the locators that we call them, they're able to receive up to 600 packets per second. That's what we publish. I think the performance actually has exceeded that in certain cases. But again, that's on a per locator basis. In terms of how far away the coverage question that you mentioned, the way that this works is that it provides a cone of coverage, and it's kind of similar to lighting. If I can draw an analogy, the higher I mount it, the more efficiently I cover the space. It's similar to lighting. The higher I put a light, the more easily I can illuminate a larger space. And so the way that the technology works is that by having more than one locator receive a transmission, that we are calculating the angle of its arrival relative to each locator that's received it. And thus, creating from a data perspective, it's the intersection of those perspectives that allows us to have precision. So by having more than one locator that's receiving that signal, we're able to calculate the position from a variety of different perspectives. And so that's where we get the precision. That solves the problems, or mitigates the problems of obstruction. It mitigates the problems of absorption, because if you have people in the environment, people are big bags of water. That also can cause a problem when you're trying to calculate position all the time. So, but one can see while the other one, or hear in this case, whether the other one does not, or may be blocked or obstructed. So that's part of the solutioning that goes into this, so that you can provide accurate position.
And then maybe last question on this topic: security and privacy. Is this an issue that you have to address, or is this more of an issue for whoever is developing the application to make sure that the data is stored and used in a secure and private manner?
There's a twofold question to that. Normally, I would answer on a sales call. I would normally answer it's the upstream. It's the latter question or the latter example there. It's the software provider that is the one that's going to be doing the association of the tag with whatever it is that they're associating it with, whether it's a person or a thing. But in reality, there's also the notion of security that happens in the transmission itself. There are some enhancements that we're bringing out for secure transmission. Our locators are secure in that they send the packets back to the positioning engine in an encrypted fashion. So there's security, at least at the fundamental side, but the real security that concerns most people happens at the association, when that happens at the application layer.
Tom, I'd love to walk through a few case studies with you, but before we do that, is there anything on the tech stack that we missed that's important to touch on?
No, I think we covered it in a haphazard way. I tend to be tangential, but I guess the piece that, in terms of, we're known for delivering accurate positioning. I guess the main thing that I wanted you to walk away with, that you can have a variety of different tags that you can use on these tags. Using a tag ecosystem is, again, another differentiating point. A lot of other solutions tend to be very proprietary. And so this makes it a lot more flexible from a cost perspective. It allows you to go find and develop tags that may not only just be providing positioning, but may also be providing other IoT information like temperature and other things that you may be trying to measure in the space. But yeah, let's talk about some use cases.
Great. Yeah, I mean, are there a couple that maybe we can kind of aim for a bit of a range here? And it doesn't all have to be Industry 4.0. I think it'd be interesting to hear some of the different environments that you're deployed in.
You tempted me, and we can talk about sports a little bit. So I'll mention the hockey example. So we're used in 2 different hockey leagues in Europe, and pursuing another one here in North America. And again, that's through a partner. And the partner is tapped into, and the reason I like to talk about this is that it solves multiple solutions for multiple audiences. So naturally, the teams get the IoT or the Moneyball data, the sabermetrics, however you want to refer to it, in terms of understanding the performance of their players. The fans that are watching the game can also have some additional real-time information that's sent to their mobile devices. It's also solving the problems of, or providing a foundry of different items for the betting houses to wager on who hit the hardest slap shot, who skated the fastest, who spent the longest time on the ice, and being able to start and then of course the teams are correlating that information to understand what's the most effective strategy moving forward. And then last is obviously the television networks, by being able to provide some augmented reality with in identifying the players on the ice, and whether that's through replay or whether it's actually happening in real time. It's a multifaceted approach. We are doing essentially the same thing there that we are doing in industry, where we're tracking fork trucks or AGVs, pallets, and so forth that are moving around dynamically. In a lot of cases, for example,
Tom, sorry to interrupt you, but just one point on this hockey example. I'm very curious how this business model works. Is this then your partner owns the data and then they monetize the data by selling it? Because I think you mentioned, 4 or 5 different stakeholders that all find value in this. So is it your business partner that owns the data, or is it the hockey league? And then the hockey league determines who can gain access. Do you know how that works?
Yeah, you mentioned the hockey league, and obviously that starts to get into a lot of touchy situations there in terms of who really owns the data. But yes, it is marketed from our partner to those different audiences and monetized in a variety of different ways, I'm sure. So we just produce the data. That's all we do. And in fact, we don't even store the data. We produce it and send it to them for their analysis. In the case of the analogy that I'm drawing, whether it's hockey, whether it's animal husbandry, whether it's hospitals, whether it's Industry 4.0, we are doing the simple task of providing the information of where something is, and with a timestamp. The things that people are doing with that, and again, I love to tell that story because it's not just to support the team; it's to support all these other use cases. In the healthcare, as an example, when they implement this in a hospital, they may be trying to do something very simple like protect for doing hand washing compliance, which actually is not very simple, but it's an immediate use case that everyone needs to have solved, where they want to assess, did the healthcare worker wash their hands when they walked into a patient's room, or did they go straight to the patient? And if so, did they, is there a corrective action that can be taken? And whether you're solving for that problem or whether you're doing baby abduction, if an unauthorized person is now transporting a baby through a door or gets close to the door, should the door lock or not? And so, hospitals are worried about security in that regard. Things like tracking the crash cart and making sure that it's where it should be from a compliance perspective, and helping the nursing staff operate more efficiently as they, have to maintain and keep that up to date. So those are all a bunch of different use cases, as an example, that are all facilitated by the same infrastructure. You may have different tags that are transmitting at different levels, different form factors, and so forth. But essentially, we're doing the same thing. We're providing that data to an upstream intelligence platform that's making business decisions on the information we're providing. In industry, we were talking a little bit about the worker safety aspect with COVID and social distancing. I mentioned collision avoidance. There's also mustering for employee evacuation. There's also worker tracking. We have a number of examples where companies are providing or analyzing the metadata of where their workers are in positions around a plant, so that they may be able to, work more efficiently by, staffing in a different fashion. And the logistical space, it's actually one of the examples that we have. In the case of another example of worker tracking and collision avoidance, you may have the AGV taking a more circuitous route whenever they see a gaggle of people that are congregated at a certain place on the factory floor, as an example. So just taking taking the long way around, the long way home for the AGV may be the easier way for it to solve that problem, as opposed to immediate notification, which is what most people think about in the case of collision avoidance. So then of course, there's the equipment inventorying and being able to do, man down detection and things like that, as well as visitor tracking. These are a lot of different examples that we would see just from the security and safety aspect. The operational efficiency piece, where I think early on I gave you guys an example of, where the post-production, we had a specific customer that made steel coils, and all the steel coils looked the same, but they were all destined for different customers. And, it was hard to understand which one was for which customer by just looking at them. And so it would take them literally half an hour to 45 minutes to find and locate them. And they realized they were spending an inordinate amount of time trying to track these assets, and as well as manpower, because they had to physically send people to try to go find them. And sometimes these coils were stacked X deep against a wall, and they had to move the other ones out to get to the one that they were trying to find. So that process in and of itself was a lengthy one. And now they were able to find things in less than 5 minutes. So that process allowed them to cut their staff time by like 20%, realizing an immediate return, delivering products at a faster pace to their customers, getting the products there. They had customers that were waiting in the parking lot, with trucks, which of course the meter is running like it's, if the truck is just sitting there and not being used. So, and a lot of times they were being asked to produce rush orders for their customers. And in this particular case, they had to drop everything, produce the product, and then send to customers, all because of the product not being found in a timely fashion. In many cases, it was still on the factory floor, but they had to go back and produce more of it. So not really an efficient way of operating. By putting this platform in just to do location of their assets, they realized that they were able to realize a 30% increase in the amount of shipments on a daily basis. And that's real money. That almost made the ROI happen in less than 2 weeks for the entire system. So kind of an exciting, just when you think about, okay, we're going to operate a little bit more efficiently, but what's that really mean? And the company really didn't expect to understand that they would be actually shipping more product out on a daily basis and from a production perspective. And again, they weren't doing production runs or emergency production runs either. So a multifaceted realization just from something that's very simple, like tracking and tracing.
Oh, very interesting. I mean, there's really no more universally valuable data set than the location of things, right? I mean, this is kind of the one data point that pretty much every organization in the world somehow would find value for. So then it becomes really a question of going through and saying, okay, how do we prioritize and how do we ascribe value to actually knowing the location. And I suppose that's always for you a big puzzle going into or for your partners going into an organization and saying, okay, right now you want to track the location of this specific thing, but what else might be interesting here, right? Once you have the infrastructure in place. And I imagine pretty quickly you can put together a laundry list of different use cases, large and small, that would also somehow be enabled by that.
One of the things in work in process is the other thing we really haven't talked too much about, but being able in aerospace, as an example, is a strong one where the skill sets of, it's still a manual process in many cases. The skill sets of each worker is highly refined to do a certain task. And so being able to, and as well as the tools, it's amazing to hear this story, and it's universal in the aerospace industry where they're trying to find tools. And, so being able to find the correct tool or the right implement that, to repair an aircraft at the time is a huge inefficiency that's in that industry. Again, and we're speaking whether it's repair or whether it's manufacturing. It's both are similar functions. So some of the things that we've learned in that specific space is also the security that goes along with that, because we don't necessarily want the information getting into the wrong hands, whether that's industrial competitiveness or national competitiveness.
Gotcha. Interesting. Tom, one last point I wanted to touch on with you. What's around the corner? So I understand you are, let's not say bootstrapping, but you're growing organically, which I think is quite normal for a B2B company. I imagine what that means also is that you have kind of a steady technology development roadmap. What are the areas where you're focusing on improving the specifications, enabling new functionality? What are the priorities that things we see roll out in the next couple of years?
Based on the size of the company that we are, it's not like this industry is still in its infancy. And while we may have a great technology that provides accurate positioning, people that you work or are working with us from a scaling perspective, we really want to be able to help them scale the business much easier. So making it easier for people to have positioning is really where our focus is going to be. And whether that's in the commissioning of our technology, helping people install it easier. It's already a fairly simple process. And again, I'll contrast it to other technologies that may be require a level of expertise. This can be installed by lay people. If you know how to run cables, then you can certainly learn how to install our technology. Again, making it simpler and things like self-commissioning. That's a panacea in the future, but it's something that we are striving for. You asked one of the technologies, though, that I think that's going to really affect this particular business that is not even something that we're in the process that we're involved in manufacturing ourselves, but affects our business would be energy harvesting. And so that alone would bring down the cost of the tags and allow projects to expand beyond the thousands of things that we track in a typical installation to be something that's, to expand beyond that. And it would kind of get us into that passive RFID tag cost space. So that's something that I look forward to in the future from other tag manufacturers. I think it's really going to be disruptive.
Yeah, interesting. No, I just had somebody send through a pitch deck on that. I see there is a lot of interest in development work going on there. So it'll be interesting to see what comes out in the next 5 years or so in that domain. Tom, thank you. I've really enjoyed the conversation. This I think is a super interesting space. The topic comes up all the time in projects that we're running, and I'm glad that now I understand more about Quuppa and where you position here. What's the best way for somebody to reach out to you or to your team if they're interested in learning more?
Email us at Quuppa.com. They can go to or info@Quuppa.com or visit our website at Quuppa.com. There's a variety of different ways to inquire and to engage us there, whether you are a tag manufacturer or potential tag partner, or whether you are a potential software company that would like to use our location data.
Great. Well, Tom, thanks. Really appreciate your time today.
Eric, thank you. It was a pleasure. Hope I didn't meander too much. And it was certainly a pleasure to discuss the Industry 4.0 with you.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT ONE HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.